Hello, and welcome to T-Level Tactics, and this video on access controls for Root Core 3 data of the T-Level Digital Support Services course. And in this video, we're going to identify some different access control types. We'll explain the use and functions of APIs, and we'll also compare some different access control methods. Before we get started, these videos are not endorsed or sponsored by any education, institution, or qualification awarding body. And T-Level Tactics videos should not be used as a replacement to any classroom learning you might be receiving, as the discussion and practical activities with your peers and lecturer will help to expand your thinking and comprehension. Instead, these materials are best used as preparation material or as revision to reinforce your learning. And these videos cover the same content of required knowledge for Root Core 3 of the T-Level Digital Business Services course, however, will be more contextualized towards IT support roles. Let's take a look at what access control is. In today's digital landscape, organizations face increasing threats to data security and privacy. And with the rise of remote work and cloud computing, managing data access has become more complex and critical. Organizations must balance accessibility to data with data security to ensure that users can perform their tasks without compromising data integrity. Effective data access management is essential for protecting sensitive information and maintaining compliance with laws and regulations. User access controls are security measures that determine who can access specific data and resources within an organization. All data requires access control to protect sensitive information from unauthorized access and potential breaches, and ensure compliance with legal and regulatory requirements regarding data protection. Access control methods can include physical access, remote access, permissions, and user authentication. Let's take a look at what some of these are. Physical access includes the management and control of physical access of people to a facility, hardware, and/or specific equipment. And it can help protect sensitive areas like server rooms and data centers from unauthorized personnel. We don't just want anybody being able to walk in and get access to this equipment. It ensures the security of physical assets, reducing the risk of theft, vandalism, or tampering. But it can be particularly costly to implement, and it relies on people to follow these policies and procedures we put in place to the letter in order to work correctly. And this is where the problem is, as we're still human, and humans can still make mistakes. Physical access control methods can include things like keycards, which are electronic cards that grant access to authorized individuals, and they can be programmed for specific access levels, times, and even specific rooms or buildings if we want to. It includes biometrics, things like fingerprint and facial recognition or iris scanning technology for secure access. We can have security staff to monitor access points and enforce protocols and conduct regular checks and respond to incidents if we need them to. And surveillance like CCTV cameras to monitor and record activities in and around these sensitive areas we're trying to protect. And this can help to deter unauthorized access, and if there is any, can provide some evidence in case of a security breach. Physical access controls can be further defined by different access levels and roles. For instance, visitors and contractors can be given temporary access to specific areas or prevented from moving around a building at all, and employees can be given access to rooms and equipment based on their role and requirements, so they're not going anywhere that is irrelevant to the work they're doing. Remote access is the ability for users to connect to an organization's network and access data and resources from off-site locations, such as if they're going to visit a client at another building or if they're working from home. And it facilitates this flexibility and productivity by allowing employees to work from almost anywhere. It's essential for supporting remote work, especially in today's increasingly digital and mobile work environments. We can remotely access networks and organizations through technologies like VPNs or virtual private networks. These create a secure, encrypted connection over the internet, allowing users to access organizations' networks safely. It also protects data in transit from any eavesdropping and interception from third parties. And there are secure remote desktop protocols that are known as RDP or VNC, Remote Desktop Protocol, or Virtual Network Computing. And this allows users to access their work computers securely from different remote locations. And they ensure that sensitive data remains within the organization's network. There are also remote access gateways, and this is more specialized hardware or software that could provide users secure access to internal resources from external networks. And these often include features like authentication and traffic filtering. Managing remote access can be tricky, and there are risks. In terms of security risks, there is an increased vulnerability here to cyber threats such as phishing, malware, and unauthorized access if people are accidentally giving information away that can give access to this remote access technology. There's also network reliability issues, and it all depends on stable internet connections wherever you're trying to remotely access a network or a computer. And this can affect productivity if connectivity issues arise. People trying to do work remotely from a coffee shop, for instance, or on a plane, not going to have the best internet connections available. And there's also compliance issues here with people following the rules, ensuring that remote access practices comply with data protection regulations and organizational policies. So perhaps working from a coffee shop or a plane actually isn't the most secure way of going about your work. Permissions are rules that determine what actions users can perform on specific data or resources within an organization. And they ensure that users have the appropriate level of access based on their roles and responsibilities. And they should hopefully minimize the risk of data breaches by restricting access to sensitive information. There are different types of permissions that we granted to users. There's a read permission, which will allow users to view data or files but not be able to make any changes to it. And this is going to be essential for users who need access to that information but not modify it. There's write permissions, and this will grant users the ability to modify or add data. This is important for users who need to update records or create new content. If users have a write permission, then they are also granted the read permission. There's an execute permission, which enables users to run executable files or applications on a computer or on a network. And this is going to be necessary for users who need to perform specific tasks or operations. And there's the delete permission. And this will allow users to remove data or files from the system. And this should be granted cautiously to prevent accidental loss of important information or data. With permissions, users could be assigned access based on their role or position. There are two different methods to control permissions. There's role-based access control, or RBAC, and this assigns permissions based on user roles within the organization, ensuring that users only have access to what they need. And there's also attribute-based access control, or ABAC, which uses user attributes such as their department or location to determine permissions, allowing for more dynamic and context-aware access, meaning they might be able to get access to some higher security files within their own department, but nothing at all within somebody else's. There are still some risks to using permissions, even with combinations of other access control methods as well. There is a level of complexity here, as managing permissions can become complicated, especially in large organizations with diverse roles, responsibilities, and multiple departments. And it's possible to over-permission something and grant excessive permissions, leading to potential security vulnerabilities, particularly if people work in multiple departments and have different permission levels in each. And there needs to be some regular audits of permissions to ensure they work correctly, some ongoing reviews and audits of these permissions to ensure they remain appropriate and aligned with user roles as organizations change and users get different roles and do different work within the business. User authentication is the process of verifying the identity of a user before granting access to systems, applications, or data. And it ensures that only authorized users can access sensitive information and resources. It can help protect against unauthorized access and potential data breaches. Authentication methods include passwords, which is probably the most common form of authentication, requiring users to enter a secret word or phrase. And there is an importance in having strong password policies to make sure this works. Things like having complex passwords, long passwords of maybe 5 or 8 characters in length or more, and having password expiration dates to ensure that users change their passwords regularly. It can include biometric authentication, and we've mentioned this before, using someone's physical characteristics such as fingerprints or facial recognition to verify their identity. And this can provide a high level of security as biometrics are very difficult to replicate. Most of us are all unique, hopefully. We can also use multi-factor authentication, or MFA, and this can require users to provide 2 or more verification factors, such as something they know, something they have, something they are, perhaps even using a phone or another device that they always have on them to make sure it is them. And this can significantly enhance security by adding layers of protection beyond just passwords. And we can now also use one-time passwords as well, which can be temporary codes sent to users via text message, email, or authentication apps for a single login session. And this reduces the risk of credential theft, as the code, the password, is valid only for a limited time and for that access. Having users enter passwords multiple times for every system can create user fatigue and complacency. So we could use something called single sign-on, or SSO. And single sign-on can help reduce this, provided the user has logged in recently and has authenticated themselves. SSO, or single sign-on, allows users to log in once and gain access to multiple applications without needing to re-enter their credentials. And this can help improve the user experience and reduce frustration with signing in multiple times while maintaining security. There are some risks to authentication, such as user resistance, which may mean that users are resisting adopting more secure authentication methods due to perceived inconvenience, like switching to multi-factor authentication and using authentication apps on their phones, for instance. There's also a balance of security versus usability, and balancing strong security measures with user convenience to avoid hindering any productivity. It can take time to work authentication apps and do multi-factor authentication multiple times a day. There's also the cost of implementing these security measures, and it does require investment from organizations and businesses in these advanced authentication technologies like biometrics and multi-factor. It can become costly. So that's a look at some different access control methods. And if you're a member of the Patreon, you can head over to patreon.com/tleveltactics and download the task sheet for this video. Have a go at the first task. It should take somewhere between 20 to 30 minutes. If you're not a member of the Patreon yet, head over to patreon.com/tleveltactics to take a look at all the content that our members get exclusive access to, including these task sheets, our podcast editions, and more. Pause the video here, have a go, then come back when you're ready to move on to part 2. In part 2, we're going to take a look at APIs. An API, or an application programming interface, is a set of rules and protocols that allows different software applications to communicate and interact with each other. And it facilitates the integration between different diverse systems, enabling them to work together seamlessly. It's like a layer in the middle between them. APIs can enhance functionality by allowing third-party applications to access and utilize data and services from other platforms, but in a secure manner. And there are different types of APIs. Open APIs, known as public APIs, and these are available to, essentially, anybody, external developers, and any third party, which allows innovation and collaboration between different software. There are internal APIs or private APIs, and these are usually used within organizations to facilitate communication between internal systems and applications not usually available to the public. And partner APIs, which will be shared with specific business partners to enable collaboration and data exchange. There are three key components to an API. Endpoints, which will be specific URLs where API requests are sent to access particular resources or services. The request or response format, which defines how data is sent to and received from the API, using common formats like JSON or XML that we've looked at previously. And the authentication method, which will be the mechanism to verify the identity of users or applications accessing the API, such as API keys or OAuth tokens. And there are some benefits to using APIs. There's increased efficiency, as APIs streamline processes by allowing applications to share data with each other and functionality without any manual intervention. There's scalability, as it enables organizations to easily integrate new services and technologies as they grow. And there's an enhanced user experience, as APIs allow for the creation of more dynamic and interactive applications by leveraging external data and services. And all of this they can do in a secure manner, making sure they can only access data that the users are intended to, and not everything all at once. There are some challenges that come with APIs, though. There are still security risks, as APIs can be vulnerable to attacks such as data breaches, DDoS attacks, etc., if not properly secured. Think of Twitch, for instance, where there's an API that allows you to link Twitch to other software applications, and if that key is made public and available to lots of people, then people can take over a Twitch channel and do other things to it that you're not intending. And that goes for other platforms as well, like YouTube. There's versioning and compatibility issues. Managing changes to APIs can lead to issues with existing applications. Everybody needs to be using the same versions to ensure compatibility. And there needs to be some documentation on how to use APIs. Comprehensive documentation is essential for developers to effectively use these APIs, and poor documentation can hinder the adoption of them and the use of data in other applications. So that's just a very brief, quick look at APIs. And if you're a Patreon member, there's a task on the task sheet related to this. So head over there, have a go at the second task. It's only going to take about 20 minutes. Pause the video here, have a go, then come back when you're ready to move on to part 3. Finally, we're going to compare some different access control methods. They're going to be quite specific. We've briefly looked at some different access control methods, but there are some more specific controls in software that we need to understand. Software permissions can be further defined and controlled using a number of different control methods. There's role-based access control, RBAC, which restricts or allows access to resources based on the role of a user. Attribute-based access control, ABAC, which restricts or allows access based on attributes or characteristics. There's MAC, or mandatory access control, which will restrict or allow access based on a hierarchy of different security levels. Discretionary access control, DAC, which restricts or allows access based on resource owner preference. And rule-based access control, RUBAC, which will restrict or allow access to resources based on rules that are independent to the user's role. Let's start with role-based access control, or RBAC. And this is where access is granted or restricted based on the user's role within the organization. Users are assigned roles such as admin, user, or guest that determines their access rights. And this is commonly used in enterprise environments to ensure users have access only to the information necessary for their job functions. And this can help to simplify management of user permissions and enhances security by limiting access based on job responsibilities. With attribute-based access control, access is granted or restricted based on user attributes such as departmental location and resource attributes. And policies we set can evaluate these attributes to make dynamic access decisions based on who's trying to access the data and what kind of data it is. And this is useful in environments requiring fine-grained access control such as healthcare or finance. ABAC provides flexibility and context-aware access and allows for far more granular control compared to RBAC. With mandatory access control, access is determined by a central authority based on a hierarchy of security levels, such as confidential, secret, not secret. With mandatory access control, users cannot change access permissions. They're enforced by the system. And it's commonly used in government and military settings where data sensitivity is critical. Mandatory access control is a strong security model that minimizes the risk of unauthorized access and ensures compliance with strict security policies. In discretionary access control, access is determined by the resource owner, who can grant or revoke permissions at their discretion. Meaning if you've created the data, you're the one that can set the access levels. With this, users have the ability to manage access to their own resources, as opposed to mandatory access control that we mentioned earlier. And this is common in personal computing environments and smaller organizations that may not have any central control on a server. Discretionary access control provides flexibility for resource owners to control access themselves. And it's simple to implement and manage as all users have to deal with it themselves. But that does raise some security issues if people aren't managing their permissions correctly. And finally, rule-based access control, where access is controlled based on predefined rules that are independent of any user's role. And these rules can be based on conditions such as time of day, location, or specific events. Rule-based access control could be particularly useful in scenarios where access needs to be governed by specific conditions such as compliance requirements. And it allows for dynamic access control based on situational factors, enhancing security by enforcing specific rules regardless of a user role. So let's take a look at some of these different methods. We've got RBAC and ABAC. RBAC being role-centric, while ABAC is attribute-centric, allowing for more granularity. MAC and DAC, where mandatory access control is enforced by a central authority, whereas DAC allows resource owners to control access themselves. And RUBAC, which can offer flexibility by applying rules, can adapt to various conditions and complement the other methods. Now, these methods can be used in combination with each other, but you don't have to. Organizations can choose what kind of access control methods they want to implement, but choosing the right one is critical depending on the organization that you're working in. There are multiple reasons why you may want to use one access control method over another, and organizations will need to evaluate their needs to determine what is most suitable for them. Understanding each method is key to implementing effective security on computer systems and networks. So for Patreon members, you can head back to the task sheet and have a go at the third and final task. This is going to be looking at different control methods and will take you roughly about 50 minutes to complete. So have a go at task 3, pause the video here, have a go, come back when you're ready to finish things off, and we'll take a look at some short exam questions. So in this video, we've identified some different access control types. We've explained the use and function of APIs. We've also compared some different access control methods. Let's finish off with a couple of exam-style questions. Here's the first one. Explain the concept of user access controls in a digital environment and how they enhance data security. And the second, compare rule-based and attribute-based access control methods and where they would be most appropriate. And that brings us to the end of the video and the end of Root Core 3 data if you're watching us on YouTube. Patreon members who are signed up as T-Level Tacticians have exclusive access to a Patreon project, which is an extended project that will put all of your knowledge and learning to the test. So, if you're not a Patreon member, head over to patreon.com/T-Level Tactics to get signed up and get access to that Patreon exclusive project, and also all the other exclusive content that our members get, including podcast editions, task sheets, and other resources that are available on there as well. If you're not a Patreon member, make sure you're subscribed at youtube.com/@T-Level Tactics to keep an eye out for any future videos we release. Thanks for watching.